Nicholas, and this is the third video, and I'm going to show you a quick introduction on how to do the maximum likelihood estimation in Python. In this video I'm going to use the statsmodels package, and I'm not gonna in the statsmodels page you can click on examples and you can get examples on how to do basically everything from ordinary least squares, weighted least squares, plotting tools, just about a lot of stuff, basically time series, and and here you have though in the end the generic maximum likelihood model, and I will just show you one of their boilerplate models. For some reason I've chosen the negative binomial regression for count data. The entire thing is explained pretty thoroughly here. This example is slightly more programmatically advanced than the OLS situation, which I showed you before. Basically, it was just stuff calling and variable creation. This time I will do something a bit more interesting, programmatically speaking. Yeah, so let's get started. I have already done this example, so I will just basically walk you through it. It's a good way to just get used to it and write down the code yourself. But in this particular example, there's a lot of stuff that that would take a lot of time to go through. Because basically you can just copy this into your program. Not that one. And not that one. I want this one. I want to open that with Sublime. Alright, so in this package I imported NumPy, SciPy stats, from which I got the n binomial distribution. And you can just check it out here on SciPy stats, and you can read about the documentation about all the different characteristics about how you should use it, and different methods that come with it. So you can get the CDF and the var, mean standard deviation, and even even a method for getting all of it in one run. Log of probability mass function. I think that is the one that we will be using in this example. Alright, so let's go through it. So it's the SciPy stats and binom, and then the stats base model for generic likelihood model, and it's case sensitive, so remember that. And then basically you create one function for the log likelihood where you define a method for the mu, which is numpy.exponent function, and then np dot basically, and that's basically for creating mu over your variables, and then you create size and the probability, and then the log likelihood where you use the n binomial function, and you get to that this log of the probability mass function with x and p and location. But you don't do the lock. Alright, and then this function will return the log likelihood function. However, our big thing right here is that we use the class nbin. This is gonna be what, in comparison to our OLS example, it will function as this. Because when we call this later on, it will we will just have to write our nbin and then the endogenous and exogenous variables. And within this nbin class, we have the three functions: the initialization function, which I'm not going to go into too much detail, and then the n log likelihood observation, which uses this, which will take the parameters, and then it will to estimate some beta and alpha, and run it through this little function to retrieve the log likelihood. And then there's a fit function, which will have some bounds, and yeah, basically use the fit function depending on the parameters that it will evaluate. Alright, but the fun thing with this is that we can create now a new thing. Let's save this little piece, testing mla.py. Alright. Because the point of using a programming language, as we are doing right here, is that we want to be able to extract the info. Like, I've created here the MLE n binomial.py, and I could change this into becoming almost any, based on any different kind of basically any kind of distribution. We could just Google SciPy distribution, and hopefully we'll get a list of the different kinds of yeah, exactly. We have the n binomial right there. We have the Bernoulli binomial, Boltzmann, Laplace, geometric, logarithmic. Yeah, so there's a bunch of different distributions we can use, and the cool thing about it is that we can edit this file into being adapted to all the other kinds of distributions, so that later on when we are working with it, we could just use I'm gonna show you a small quick case on how to use this file as my estimator in a separate program, basically. So we will use our recently created Python program as we use with the NumPy, for example. Alright, so basically it's just like with the module. You just write from, and this file is called mle_nbinom.py. So it's from mle_nbinom, nbinom. You don't need a py, and then we want, from this we want to import nbin. We will also want to import pandas as pd, and import patsy because we want to handle some matrices. I will be using in this example of I will be using the example data that you can find in the example case right here. There we have it. Alright, there we have it. We're just gonna copy this into there and put quotation marks so it will be used as a string. Then our variable medpar is equal to pd dot read underscore CSV, which is the pandas tool for reading CSV files, and then it will read our URL file. Then we will define x and y the y variable and the x variable. And we will do this by using the patsy matrix tools, which you call by writing patsy dot d matrices. I don't think it's gonna be matrices. Wait, we could just first do like this. Try, does this work? It does. We can write med par dot head. Alright, so we know the first 5 rows of this. Now we can write loss as our y variable, and then loss, and then the squiggly sign, and then we will basically think of it as an equation. So it will be type 2 plus type 3 plus HMO plus white, and then med par, so it will know that we want to use this file. So from this, so patsy d matrices takes from this file and makes a matrix equation based on that. And then we can just write model is equal to n bin, which is our function from our old example of the maximum likelihood. And in this, we'll just press y and x as our endogenous and exogenous variables. Yes, as you can see, you just your y and your x. And yeah, let's see what happens. It seems to work. Alright, so it tries that out. What if we do this? Model.fit hopefully, yeah. It optimized successfully. That is exactly what we wanted. And now we would also just want to try to do this print model dot summary. I think no. Alright, we just need to do the result is equal to model dot fit, because it will depend on another thing. Now we can do it like this. Print result dot summary, then open close brackets, and there you go. You have the results of the maximum likelihood estimation for the negative binomial distribution. And as I said, you can just change this into being following another kind of distribution, and then in here you can just from your Emily, you'll just create a new file, Emily Bernoulli import and Bernoulli, and then you can just replace this by Bernoulli, and it will be, yeah, it will depend on what you want to do, but it's when you write more code, this will become the most flexible and easiest way to run your analytical stuff in. All right.